So now let's talk about line integrals. And again, we're going to recall some facts that we should know. So if we look at an integral from a to b of a function, right, what are you doing? You're computing the integral over an interval, a to b. And in this class, we've looked at a double integral over a region R. This is an so we know how to compute over an integral. We know how to compute over a region. And so now we're going to look at a new type of integral called a line integral. And so what is a line integral? We're integrating a function f of xy ds over c over a curve c. And here it's ds. So if c is given by x of ti plus y of tj, where t is between a and b, then the way we're going to write this line integral, the way we're going to compute it, this is the integral from a to b, you're going to replace x by x of t, y by y of t, and then this ds, s corresponds to the arc length, and so it's going to be the square root of x prime t squared plus y prime t squared dt. And there's also a three-dimensional version of this if c has a z component. I do want to mention, so note, if the function, if f of x, y, z is 1, then the integral gives us the arc length of the curve C. So let's look at an example. Let's evaluate the line integral C, x squared minus y plus 3z ds, where C is the line segment shown. So C is going to correspond to the line segment coming out of the origin and ending at the point 1, 2, 1. So the first thing you want to do is you want to write parametric equations for the line segment. So here, if I'm talking about t being between 0 and 1, I can write the parametric equations as x equals t, y equals 2t, and z equals t. So I've got my parametric equations. I'm also going to need the derivatives here, x prime. So let's go ahead and find those. Y prime is 2, and z prime is 1. So now I'm going to plug this all into my line integral. This is the integral. T goes from 0 to 1. It's this part here. And now I'm going to plug in these formulas in place of here. So if I plug in t for x, I'll get t squared minus 2t plus 3t. And then ds, remember, this is x prime squared, 1 squared plus 2 squared plus 1 squared. Well, that's the square root of 6, which I can go ahead and pull out. This is t squared plus t. And then you just do your reverse power rule, t cubed over 3 plus t squared over 2 from 0 to 1. And if you plug in, you should get 5/6 over 6 as your answer. And I do want to make one final note on this example. So note the value of a line integral does not depend on the parameterization of the line segment C. So remember, when you're working with parametric equations are not unique, and so you could have written down a different set of equations, but in the end, you should get back the same value for the line integral, regardless of how you write down your parametric equations for that line segment.